Hello, everyone, and welcome to Florida Data Science Academy's third tutorial in the 24-part series Intro to Data Science. I'll be your instructor, Dylan Sinnickson, and today we'll be going over a lot of very important concepts for being a data scientist. In particular, we'll start off by reading in data and then working with messy data, and then we'll be using the dplyr package to filter, group by, and summarize our data types. So I'll start off by installing a couple packages that we'll need to work with today, the first of which will be the stringr package. So I'm going to install a package and type in stringr, and then I'm going to install the package. We can see that in our console, R is working on that installation. And then I'm going to click and install, and then I'm going to type the dplyr package, which is right there. dplyr is actually one of the most important packages in R. It's one of the most frequently used as well. And then we can move into our R script, and we can call the library function, and then we're going to call stringr. And then we're going to also call the library function again to type in our dplyr package. So we can run lines 1 and 2, and I'm going to write a comment to myself, which is going to be called reading in data. And I'm going to type working with messy data. So in addition to working with all of the analytical and statistical techniques that are essential for being a data scientist, actually one of the most tedious and important tasks for being a data scientist is actually just cleaning up data and working with messy data types. So today I actually created a couple different data sets that are particularly messy that I hopefully we will be able to work through, so I can teach you how to clean up a messy data type. So first of all, we have to start off by reading in the data. So how do we read in data from either an Excel worksheet or a CSV file into R? So how we do this is we start by we set a working directory. So I'm going to use the setwd function, and then I'm going to copy and paste the link to the folder that I would like to set my working directory. So I'm going to go into my folders here, and then I'm going to, obviously my working directory is going to be different than yours. I created a folder called Florida Data Science Academy. I'm going to right click on the folder of interest. I'm going to click copy address as text. Then I'm going to minimize that folder, and then I'm going to use a single quotation, and I'm going to paste the link to that folder into my R script. So hopefully you guys were able to download I have this lumber sales CSV file that hopefully I attached to the YouTube video as well as to the Florida Data Science Academy website. So we'll be working with the lumber sales.csv file. I've stored this file on my working directory, which is I entitled Florida Data Science Academy. Your working directory is going to be different. This is just going to be where you saved your lumber sales CSV file to. So if you're actually working on a PC, something that is somewhat annoying is that we have to change the direction of these dashes. So currently they're going from the top left to the bottom right. We actually have to change the direction of these, which is kind of tedious, but I think on a Mac you don't have to do this, but on a PC you do have to change the direction of these dashes. So I'm going to run on line 7. Looks like R was successful at setting our working directory. And then I'm going to read in the lumber sales CSV file. So I'll start off by creating an object called lumber sales. And then I'm going to use the read.csv function. So this is a function that obviously reads in CSV files into R. And then I'm going to use a single quotation. And then on a PC, I'm just going to click tab. And then R is actually going to already link to the folder that I've set as my working directory. I'm just going to scroll all the way down to the L's. Hopefully I have a CSV file called lumber sales. So I will click lumber sales.csv. And then I'm going to run line 8. And we see that the lumber data set is now showing up in our environment. So I can open up this lumber sales data simply by clicking on it in the R environment. And then we can see we get this window that opens up in our R script. And you're probably thinking to yourself, this data set looks very unclean. It looks very difficult to comprehend. And you would be correct, because we have our column names that seem to be relatively meaningless. Our first four rows don't even have any data in them. We can even see that there's some inconsistencies in the typing. We have uppercase and lowercase for our customers, and some of the misspellings in this, maybe something called a product column. So this is a messy data set. This would be something that's very difficult to work with, but you have to clean it up before you can start doing statistical analyses. And this isn't unique to this data set. Almost every single data set that you will work with as a data scientist is going to require a significant amount of data cleaning. So the first thing that we're going to have to do is clean up these first 4 or 5 rows that have no data in them. So we want row 5, which seems to have something called that looks like column names. We want row 5 to be the actual column name. So we're going to have to skip the first 5 rows in order to get the column names into their appropriate location. So how do we skip lines when we're reading in data? Well, first off, we start off using a similar technique that we used earlier. We're going to read in the CSV file lumber sales. We can actually just begin to type our the name of the CSV file that we want, and then R will kind of link to it. So I'm going to click that, and then I'm going to separate by a comma, and then I'm going to use this argument that's called skip. So I'm going to set skip equal to 5 because I want to skip the first 5 rows of this data set. So when I run that, and then I can click in my R environment, and that looks much better. So we don't have all of those missing rows that were kind of making it difficult to work with. We have our column names in their appropriate location. And we do see some things. Again, we still have maybe these uppercase and lowercase issues in customer, and maybe some spelling mistakes in product, but we can work with that later. But at least we do have our column names in the appropriate location. So that's a step in the right direction. So let's take a look at we can use the head function. This is another good way of looking at data that's a little bit quicker than opening up the new window when we click in our R environment. So if I just want to look at the first kind of 5 rows of a data set, I can use the head function. And then if I run that line, we see that we get the first 5 or 6 rows of our data set that show up in the R console. So that's a good way of looking at data. It's also important to use the structure function so we can understand how R is actually interpreting the certain data types that are in our data set. So if I use the structure function on lumber, we can interpret that we have first column is transaction ID. So that's seems to be integers. They're starting at 101 and seems like they're going incrementally, maybe to 20 observations, so maybe it's going to 120. We have a customer column that is a character vector. So we have Lowe's, Home Depot. So it seems like we're working with some big retailers. We have a product column that's also a character vector. We have pine, ash, pine, cedar. So it looks like those are types of lumber. We have pounds, which are integers, and we have a price column that is a character vector, and we have some numbers here. So that seems to be an inconsistency. We would think that a price with numbers would be a numeric or integer variable, but it seems like R is interpreting it as a character vector. So we'll probably have to do some cleaning up of the price column as well. So let's start off by figuring out what are the unique elements of the column called customer. So we can use this unique function, and the unique function gives you or displays all of the unique elements and values within a certain column. So if I want to find all of the unique elements within the column called customer, I just call this unique function, and then if I run it, we can see that We have 1, 2, 3, 4, 5, 6, 7, 8 unique values within the column called customer. We have Lowe's, we have Home Depot, we have a capital Home Depot, we have a Lowe's with an apostrophe, we have Walmart, capital Walmart, Lowe's that's lowercase with no apostrophe, and then we have a Home Depot that's one word. So obviously, just using our own intuition, it seems like we have 3 actual customers. We have Lowe's, Home Depot, and Walmart, but they're all spelt differently. They all have different apostrophes and uppercase and lowercase. So this would be an example of probably someone who's entering data very sloppily and is not being very precise in their data entry. So this isn't, obviously we don't have 8 different customers. We have 3 actual different customers that someone entered the data in wrong, and we're just working with messy data that we're going to have to clean up. So the customer column is going to be an issue. Let's see if we have any other issues in other columns. So I'm going to call the unique function. Let's also check out the column called product. We can see all of the unique items in product. So it looks like we have pine, ash, cedar, another cedar, another pine, and another cedar. So again, we have inconsistencies in upper cases and lower cases. We have spelling mistakes, very annoying, but this is something that's very realistic in a real world data set that you have to be able to overcome this issue. So let's start off by cleaning up some of our data. We will have this section called cleaning up customer. We'll need to clean up this customer column, and we can start off by calling customer. So we're going to create this rewrite over the customer column. We're going to, let's start off by just setting all of the values to lowercase. So we don't want to have to deal with, the first letter is uppercase and other things are lowercase. Let's just make everything lowercase, which is consistent and easier to work with. So if we want to make all of the character elements lowercase, we just use a toLower function. So we can call this toLower. You can see it's already installed into RStudio, and we can click on it, and then we can call lumber customer. So we're going to call lumber customer, and we're going to rewrite over the previous customer, and we're going to change all of the values to lowercase. So if we run line 20, and then let's use this unique customer call that we worked with earlier. And then we can see, all right, so we're doing a little bit better. Originally, we had 1, 2, 3, 4, 5, 6, 7, 8 unique values. Now we have 1, 2, 3, 4, 5. So we did clean up some of the issues with capitalizations, but now it seems like we're dealing with some issues with spacing and also with apostrophes. So now we will move on to, let's work with the apostrophe issue. We have a Lowe's without an apostrophe and a Lowe's with an apostrophe. So we'll clean up that problem by, again, calling the customer column, and we're going to rewrite over it. So we're going to use an if-else statement. So an if-else statement basically is some syntax in R that says if we observe a certain value, we're going to want to change it to another value. And if we don't observe this original value, we do something else. So let's start off by calling the if-else statement. So if-else lumber customer is equal to, and again, I'm using the double equal sign because I'm actually trying to find if the lumber customer value is true or false equal to something. We're not setting it equal in this case. In the if-else statement, we're trying to determine a true false statement. So if lumber customer is equal to, let's say we can do Lowe's with an apostrophe. So if this statement is true, lumber customer equal to Lowe's with an apostrophe, and you notice that I started off with the double quotations, and then I used the single quotations within as an apostrophe. I believe that because if you started this with a single quotation and then ended it with a single quotation, there would be a little bit of an issue because then R would get confused with the apostrophe. So you want to do the double quotation and then use the single quotation in the middle. So if this statement is true that lumber customer is equal to Lowe's with an apostrophe, we want to change that value to something else. So what we would like to do is to change it to Lowe's without an apostrophe. So I'm going to type in Lowe's without an apostrophe. And if this statement is not true, so we've already changed it to Lowe's without an apostrophe if it does have an apostrophe. But if the value in lumber customer isn't equal to this, we don't want to do anything. We want to leave it alone. So we're going to call lumber customer, and we're just going to leave it alone. So just to recap here, we're going to rewrite over lumber customer, and we're going to determine if we find values that are equal to Lowe's with an apostrophe, we want to set it to Lowe's without an apostrophe. And if lumber customer isn't equal to this, we don't want to do anything. We just want to leave it alone and not change it. So if we run that line of code, and then we can take a look at the unique values in lumber customer, we see that now we've gone from 8 values to 5 values. Now we have 4 values. So we only have 1 Lowe's. That's good. We have 2 Home Depots and 1 Walmart. So it looks like we only have 1 more issue. We have to clean up this Home Depot spacing situation. So we fixed Lowe's and Walmart, but we have to clean up Home Depot. So how we're going to do that is, well, we can do it a couple different ways, but I want to show you a function that allows you to find which values or their location, which shows you the location of certain values in a data set, which is the which function. So I'm going to start off with the which function, and then I'm going to type lumber customer, and then I'm going to use the double equal sign, and then I'm going to type Home Depot. Okay, so the which function is going to show us the location of a certain phenomenon. So we're trying to find where lumber customer is equal to Home Depot, and the which function will give us that location. So when we run line 26, we get 18. So that shows that the row in which lumber customer is equal to Home Depot is on the 18th row. And I believe that the customer column is the second column in lumber. So the 18th row of the second column is going to be equal to Home Depot. So how do I change the 18th row of the second column in a data set? Well, we can work with square brackets, which I think we touched on class 2. But let's do another example here. So if I want to look at lumber and I want to select the 18th row of the second column, we use the syntax here is you always start with the row and then you follow with the column. So we have lumber, square brackets, 18, comma 2. So this would be the 18th row of the second column. We want to set that value equal to Home, actually we'll go lowercase Home Depot with a space. Okay, so I haven't run this yet. Let's actually just take a look at lumber. So if we want to go to the second column of the 18th row, we see that we have a value of Home Depot with no spacing. So you want to change that value to a space, and we're going to do that in line 27. So if I run line 27, and now I can look at lumber. Let's see if 18th row changed, and indeed, now the 18th row of the second column is equal to Home Depot with a space. And hopefully we have been able to fix all of the issues in our customer column, just having some spacing here to give myself some space. And then I'm going to use the unique function, I'm going to type lumber customer, and hopefully we have 3 values. Let's see. And indeed we do. We have 1 Lowe's, we have 1 Home Depot, and 1 Walmart. They're all lowercase, no apostrophes. The only space that we're using is in Home Depot. And now we've cleaned up that column. So those are just a couple different ways to clean up data. We use the toLower function, we use an ifelse statement, and we also use square brackets and a which statement to find certain locations of irregular values. So now we need to clean up the product column. So we've cleaned up customers. Now we need to clean up our products. So I'll set this section to clean product. And I'll have a couple different spaces here. And if I want to clean up product, first of all, I think we should probably look at this column. So if I want to call the unique values in lumber product, I'm going to use this syntax, unique lumber product. And then when I run line 33, looks like we have 1, 2, 3, 4, 5, 6, 7 unique values in product. But just me looking at the data, it looks like we have pine, ash, cedar, and then cedar's repeated, pine's repeated, and cedar. So similar problem that we had in the customer column. Looks like we have 3 actual lumber products, but they're all spelled differently, and that's very annoying, but we're gonna have to work on cleaning up those data in order to properly work with them. So let's start off by first rewriting the column called lumber product. And we're gonna, it looks like we have some capitalization issues. So let's just set everything to lowercase. So I'm gonna use the toLower function, and then I'm going to call lumber product. So again, we're calling lumber product, and we're going to set it equal to all lowercase values of lumber product. And I can run that line, and then I can, let's take a look at lumber product. And so we've reduced our values from, I think we had 7 originally, to 5. So we got rid of this uppercase pine, we got rid of this uppercase cedar. So now it looks like we've fixed the capitalization issues, but we do have a couple different spelling issues, I think with cedar and with pine, some missing vowels in there. So how are we going to fix that? Well, we can also use an if-else statement. So I think we're gonna want to use similar syntax to what we did in line 23, where we're gonna call an if-else statement where if lumber product is equal to these spelling errors, we're going to put the correct spelling. And if it's not equal to those values, we don't want to change anything, and we want to leave it the same. So I think we're going to actually have to use 2 if-else statements within one another. I think that would be probably called a nested if-else statement, which can be a little bit tricky, but I'll try to go through it slowly so you guys can comprehend what I'm working on here. So I'm going to call lumber product. And then we're going to set it equal to an if-else statement. And we're going to start off with if-else lumber product is double equal sign equal to this wrong spelling of cedar. If we find lumber product is equal to the wrong spelling of cedar, we want the correct spelling of cedar, right? And if it's, then I'm going to use another if-else statement. This might get a little bit confusing, but bear with me. If else lumber product is equal to the wrong spelling of pine, we want the correct spelling of pine. Put those in quotations. And if neither of these statements is true, we just want the regular values that are in lumber product. So let's work through this a little slowly. So we want to rewrite over lumber product. And we're going to use an if-else statement. If lumber product is equal to the wrong spelling of cedar, we want the correct spelling of cedar. And if that's not true, we're going to put another if-else statement. If lumber product is equal to the wrong spelling of pine, we want the correct spelling of pine. And if neither of these statements is true, we just want the regular values that were in lumber product. And then we're going to have to close with 2 parentheses because we actually use 2 different functions. We opened up with an if-else statement and then another if-else statement. So we need to put 2 parentheses to close out both of those different functions. And then if I run line 39, let's now take a look at the unique values in lumber product. And indeed, we have 3 unique values, pine, ash, and cedar. We cleaned up these uppercase and lowercase issues, the spelling errors, and now we've cleaned up customers, we've cleaned up products, and now we're looking pretty good. So Now we'll probably be moving on to the next column. I think as we just found earlier, the price column had a couple mistakes in that as well. So let's move on to cleaning up the price column. So let's start off by looking at the classification of price. So I'm going to type lumber $price. And price is actually a character, which doesn't really make any sense. There's no reason why at least in this context, there's not a reason why price should be a character vector. We can even look in our window up here, and we can look at price, 600, 500, 6,000. It doesn't really make any sense why this would be a character. And if we're trying to do a statistical analysis on price, let's say we're trying to find the mean of price or the average price, R is not going to be able to compute the mean or the mode or the maximum or minimum values of a character vector, because that wouldn't make any sense. You can only do statistical analyses of numbers, you can't of characters. So what we're going to have to do is we're going to have to change it to a numeric variable. So let's call lumber price. Then we're going to set it equal to as.numeric. And then we'll have lumber price. Okay, so I'm going to change lumber price to a numeric variable. And it looks like we have warning NAs introduced by coercion. So looks like there may have been an error. So I'm going to type out lumber price to take a look at how R interpreted lumber price. And it looks like we have 600, 500, then we have an NA, then a 600 and a 3,500. So we have looks like we have two NAs that were introduced. And I think I know the reason because I created this data set. And if we take a look at lumber price, we do have some NAs. And I think originally the issue for this was that there were commas in the price column. So I think there was a 6,000 here and it had a comma. And while other values didn't have commas. So R wasn't able to convert the character vectors with commas into numeric variables because there were inconsistencies relating to commas. So what we're going to have to do is we're going to have to read in lumber sales to get those original values. And then we're going to have to remove the commas manually. So let's create a new data set called lumber2. And we're going to use the read.csv function again. And then we're going to use a quotation and then click tab. And then you can just begin to type the beginning of that data set. And we see that lumber sales comes up. And again, we want to use the skip equals 5 argument so we can remove those first 5 rows. And then when we run lumber2, we can take a look at it. And indeed, we did have a 6,000, so there's an issue with a comma there on row 3. There's an issue with a comma on row 11. And so R wasn't able to convert those character elements to numeric variables because there was those commas in there. So we're going to have to remove those. And what the package that we're going to, or the function that we're going to use comes from the stringr package. So that stringr works with strings. So these are kind of you can think of them as character vectors that have some unique symbols in them. So if I want to take out the commas in the price column, I'm going to call number2, and then I'm going to call price, and then I'm going to set it equal to the string. I'm going to use this stringr remove. So I want to remove a certain symbol or a string within a vector. So I'm going to use stringr remove, and then I'm going to type the vector that I'm trying to work with. So I'm going to call lumber2 price. And then I'm going to use a comma, and then you can use a single quotation and another comma. So what this technically means is R is going to rewrite over lumber2 price, and I want to remove this string, or this pattern, this comma. I want to remove commas from this vector called lumber2 price. So in this situation, I want to remove a comma, but in other contexts, you may want to remove let's say an apostrophe or a unique symbol of some sort. So you can always change the argument within this section. But as of right now, I just want to remove a comma. So if I run line 52, looks like that worked out well. And let's type out lumber2 to see what it actually looks like. Lumber2 price. And indeed, we were able to successfully remove those commas. That 6,000 is no longer has a comma. I think there's a 1,000 that had a comma, no longer does. But I'm not. Let's take a look at how R is interpreting lumber to price. So it's still thinking of it as a character vector. We were able to remove the comma, but we still haven't converted it yet to a numeric variable. So that will be our next step. I'll start off by calling lumber.to and then calling price. And I'm going to set it equal to as.numeric. And then I'm going to call lumber to price. And then, so now we've successfully changed this vector price to the value that we wanted, but we're working with the data set lumber2, right? So lumber2 doesn't have all of the corrections in the customer and product column. It only has a correct price column. So what we'd like to do is all of that data cleaning that we worked with earlier on customer and price on the original data set called lumber. Now we want to combine the correct price column in lumber2 and merge it onto the original data set called lumber. So my next step is going to call lumber, the original lumber, and then I'm going to call the price column. So this is the one, lumber price is the one with the NAs and the cleaned up customer product columns. And now I'm going to set this lumber price, and I want to set it equal to this cleaned up lumber2 price. And hopefully that works. And now if I look at the original lumber, we can see that lumber price was able to successfully add in those price elements. And we can look at the classification of lumber price, and it's a numeric variable. So I think we were able to successfully clean up all of the different columns. We had to clean up customers, our products, and our price. And now we can actually start working with data. And we're going to start off by filtering, grouping, and summarizing data using the dplyr package. So I'll create a section in my code called filter, group by, and summarize with dplyr. So these three functions are very instrumental to the dplyr package. Very often when you start a data analysis, you want to use these three functions before you start doing more complicated statistical analyses, and they're often used together. So let's start off by looking at our lumber data. So obviously, as we mentioned earlier, we have a couple different customers, and let's say we want to find the mean price of a purchase from Home Depot. So how would we find the mean Home Depot purchase price? So let's start off by actually subsetting our data or filtering the customer column by Home Depot. So I'm going to create a new data frame called Home Depot. And I'm going to use the filter function because I want to filter the larger data set called lumber. And I want to just only have Home Depot values. So I'm going to filter lumber. And I'm going to filter it by customer. And I want only the customers that are equal to Home Depot. So when I run that line, we can take a look. We see that we've created a new data frame called HD, standing for Home Depot. Take a look at that data frame. And indeed, looks like we had 6 Home Depot values within lumber. And we've subset lumber for only the values that had Home Depot in the customer column. So we were successful at doing that. But now we want to find the mean purchase for Home Depot. So now we can just take the mean value of the price column And we can do that by creating an object called mean Home Depot purchase, and we'll set it equal to the mean. We've worked with the mean function earlier, mean of the Home Depot price. And then we can take a look at mean Home Depot price. And we can see that Home Depot, the average price for Home Depot is $2,200. So that's one way of filtering data and then subsequently finding the average of a column of interest. But there's also more efficient ways that you can use with the dplyr package that can kind of, we call it piping through certain functions or data. So you can kind of combine different functions and use them in very efficient ways. So often let's say we wanted to find the average price of a purchase for each customer. So we can look at our lumber data, and we have 3 different customers, and they're all purchasing different things at different prices. So let's say we wanted to find what is the average price that Lowe's is purchasing, what's the average purchase for Home Depot, and what's the average purchase for Walmart. So how are we going to start this analysis? Well, first of all, we have to group the lumber data by customer. So we can use this group by function that's installed through the dplyr package. So we want to group lumber by customer. And we're going to use this syntax. It's called piping. So I'm going to use, it's a percent sign, a greater than symbol, and another percent sign. So this is just a really efficient way of writing code with dplyr. So the group by function is going to aggregate your data set by a certain column. So we're taking the lumber data set, we're going to aggregate it or group it by customers, and then we're going to take this new data frame that this creates, and then we're going to do another analysis. So we're going to summarize the data within that are aggregated, and we want to create a new column called mean price customer, because we want to find the mean purchase price for each customer, and we're going to set that equal to the mean value of price. So that might be a little bit complicated, but I'll walk you through it. So again, we're grouping lumber by our customers, and then we're creating a new column called mean price per customer, where we're finding the mean price after we're grouping our data. And if we run lines 69 and 70, we find that we create this mini data frame, data frames working in dplyr called tibbles. It's just another formality of the dplyr package, but we have 2 columns. It's called customers, and then we have the mean price per customer. So like we found earlier, the mean price that Home Depot is purchasing is at $2,200. At Lowe's, it's $1,000, and at Walmart, it's $550. So those are a couple examples of how we can use filters and group bys and summarize 3 important functions in the dplyr package. And now I'm going to move on to our first in-class assignment of class 3. So I will start this section in class assignment. And the assignment that I would like you to work on is, what is the total amount of pounds of lumber for each customer? Each customer has purchased. Okay, so let's just think through this. What is the total amount of pounds of lumber each customer has purchased? So I think what you're going to have to do is you're going to have to use this group by function again, and you're going to have to group by customer, and then I want you to probably not find the mean. I want you to find the total amount of lumber for the column pounds. I want you to aggregate all of the pounds for each customer. So the functions that you will use to answer this question are going to be found and be between line 62 and 70. You're not going to use mean. I think you're going to use a different function. Hopefully you guys can figure out how to find the total amount of pounds, but you guys can pause the video now, work on that question, and then do it in a couple minutes. Thanks. Hi guys, and welcome back to Florida Data Science Academy video. I will be giving you the answer to the first in-class assignment. So we'll start off by calling the group by function, and then we're going to group lumber by customer, and then we're going to use the piping syntax, and then we're going to summarize by summing all of the pounds for each customer. So this new column that I want to create is called total.pounds, and then I want to set total pounds equal to the sum of all of the pounds column. So I'm grouping by customer, and then I'm creating a new column called total pounds where I find the summed value of all the pounds. And when I run that line of code, we see that the total amount of lumber that Home Depot has purchased is 1,400 pounds. Lowe's has purchased 1,480 pounds, and Walmart's purchased 545 pounds. So hopefully you guys were able to answer that question. Now I'm going to move on to another question that I think will be informative for you guys. Let's say I wanted to find not the total amount of pounds, but I want to find the total amount of purchases. So this is going to be essentially counting the amount of times Home Depot and Walmart and Lowe's are represented in this data frame. So it's going to essentially count how many Home Depots do we find, how many Lowe's do we find, and how many Walmarts do we find in this data set. So I'll start off by using the group by function. Then I'm going to call lumber and then customer. And then I'm going to use the piping syntax, and then I'm going to summarize this data set by creating a new column called purchases per customer. And then I'm going to set that equal to the n function. So this n function is essentially, it just counts. So we're grouping by customer, and then we're counting by the number of customers that we find grouped together. So what R is going to do is look through this lumber data set. It's going to group all of the customers together. Then it's going to count how many times each customer is represented. And it's going to be stored in this tibble in the column called purchases per customer. So when I run that line, looks like we have a little bit of a syntax issue here. Summarize, oh, no, there's the issue, can't have that, parentheses there. And when I run that line of code, it looks like we have found that Home Depot has a total of 6 purchases, Lowe's has 8 purchases, and Walmart has 6 purchases. So that's just showing how many times those values show up in this data set. That's quite informative. But let's say we wanted to find the mean price per customer per product. So now we're combining, we're grouping different rows together, and then we're aggregating them in a different way. So we'll start this section with mean price per customer per product. Okay, so we have a couple different products. We have, I think it was cedar, pine, and ash, and we have a couple different customers. But what price is each customer paying for each different product type? So maybe Walmart is paying more for ash than Lowe's is paying for ash as well. So I'm not sure if different companies are paying different prices for different things. Maybe the lumber industry is charging different customers different prices. I'm not sure, but let's figure this out. So we'll start off by using the group by function again, and then we're going to group lumber by customer but we actually want to group by two things. We want to group by customer, and we also want to group by products, because we have a couple different columns that we're aggregating over. So if you want to aggregate over multiple columns, you can just use an extra comma, and then you put this second column that you would like to aggregate. So we're aggregating over customers and product, and then we're piping those data through a summarize function. So we're going to summarize. We're going to call this new column that we're interested in the mean price. And the mean price is going to be equal to the sum of the price divided by the sum of the pounds. So obviously, pounds. So different companies, we'll just open up lumber here again. Different companies we're purchasing different products, and they may be having different prices, but I'm not really interested in the total price. I'm interested in the price for a certain weight, because, I think it would be comparing apples and oranges to say, like, oh, Home Depot is maybe their purchases are higher, but they're buying a lot more. But I'm not really interested in the total price that they're paying. I'm interested in the unit price, or the price per pounds that they're paying. So we want to aggregate over customers and products. And then if we want to find the mean price, actually I could put mean price per pounds. We can find the sum of the price, and then we can divide it by the sum of the pounds to find the mean price per pounds. And then if I run that line of code, we get a tibble that's demonstrated here. So it looks like Home Depot for ash is paying $3.2 per pounds. Home Depot for cedar is paying $6 per pounds, and so on. But we actually do see some differences in the prices per pounds for different products for different customers. So looks like Walmart is kind of having a difficult situation. They're getting charged the most for ash, at least compared to Lowe's and Home Depot. But Walmart's actually paying less for cedar than Home Depot is. Home Depot's paying $6 per pound. Walmart's paying $4.5 per pound. And but generally the values are relatively similar, but there are some discrepancies between the different retailers. So now we'll be moving on to our second in-class assignment of class 3. I'm just going to type a note to myself: in-class assignment. And we're going to be working with the MT-cars data set. So there's actually a lot of different R data sets that are built in with the base function of R. And one of the most frequently used data sets is this MT-cars data set. So we can actually type it in the console, MT-cars. And we can see that we have about, 8 or so different columns. We have all of these different models of different cars, and when we have data on miles per gallon, cylinders, horsepower, weights, how many gears it has, and so on. So it's actually a pretty helpful data set that's used very frequently when we're working in RStudio. And I want you, in this second in-class assignment, I want you to work with this MT-cars data set and do some aggregating and finding mean miles per gallon and maximum horsepower and so on for cars of different cars with different amounts of cylinders. So the question that I want you to answer is, I want you to find the mean miles per gallon, the maximum horsepower, the minimum weight, the last thing I want you to find is the minimum weight per each cylinder type. So we can see in our console that there's a cylinder column. So we have 6-cylinder cars, 4-cylinder, and 8-cylinder cars. And I want you to find the mean miles per gallon, the maximum horsepower, and the minimum weight for each of the different cylinder type. So you'll be working with the dplyr package. I want you to group by cylinder type, and then I want you to summarize by mean miles per gallon, maximum horsepower, and minimum weight. I think that we actually didn't, I didn't show you guys the maximum and minimum functions, so hopefully you guys can look those up on the internet. It should be very simple. So I do want you to look up the maximum and minimum functions, and we already have worked with mean pretty extensively already. So you can pause the video now and then tune back in, and I'll give you guys the answers. Thanks. Hey guys, and welcome back to Florida Data Science Academy. Now I'll be giving you the answers for the second in-class assignment. So we'll start off by grouping our data, the MT cars data set, and then I want you to group by the cylinder type. And then we're going to pipe that data set through a summarize function. And we want to create a column called mean miles per gallon, and then we're going to set it equal to the mean miles per gallon. And when we run lines 95 and 96, we see that the average miles per gallon for a 4-cylinder car is 26.7. For a 6-cylinder car is 19.7. Then an 8-cylinder car gets 15 miles per gallon. So that's what you would expect, is that cars with bigger engines are going to have lower fuel efficiency. So that's expected. Hopefully you guys were able to also find the aggregated maximum weight and minimum horsepower. So we'll start off again by using the group by function. I'm going to group the MT cars data set by the cylinder type, and then I'm going to pipe that answer through a summarize function where I'm going to find the maximum weight. The weight column, if I run those lines, we see that a 4-cylinder car has a maximum weight of 3.1. I'm assuming that's tons. A 6-cylinder car is 3.4 tons, and an 8-cylinder car is probably 5.4 tons. So as you would expect, bigger engines equals heavier cars. And then the last test that I asked you guys to do was to find the minimum horsepower for each cylinder type. So I'm going to use this pipe syntax, and then I'm going to summarize by creating a column called the minimum horsepower, and then I'm going to set it equal to the minimum value of horsepower. And when I run lines 101 to 102, we find that the minimum horsepower for a 4-cylinder car in the MT cars data set is 52. The minimum horsepower for a 6-cylinder car is 105. And then the minimum horsepower for an 8-cylinder car in the MT cars data set is 150. So hopefully you guys were able to reproduce those answers that I found. And I do want to actually just touch on one other section in our code before we end class 3. And I'm just going to call this other techniques for subsetting and aggregating data. So today we've subset and aggregated data using the dplyr package, but there are also a couple other ways to subset and aggregate data using base R. So let's start off by doing a basic subset of the lumber data set, where we just want to subset all of the products by pine. So I only want the rows in the lumber data set where the product was equal to pine. So I'm going to create this subset by using the subset function. In dplyr, we use the filter function. In base R, we can use the subset function. So we're going to subset lumber by the lumber product, where lumber product is equal to pine. And if we subset using line 108, we can look at this new Pine data set, and we get all of the rows where a product is equal to Pine. So that's another way of subsetting data in R. I actually tend to use the subset function more than the filter function. It's just a preference. You guys can do whatever you think is more appropriate. But now we're going to do another aggregation. So previously we're using group by and summarize. That's the dplyr way of using aggregating data. But there's also a base R methodology. So I want to find the average weight for each product. So I'm going to create an object called average weight product, and I'm going to set it equal to the aggregate function. So I'm going to aggregate the column of interest is pounds, and then I want to the group by function in this context is going to be a list. This list function within the aggregate argument. So I'm going to use lumber, and then I'm going to type product. And then the function that I would actually like to use is a mean. So this is a little bit complicated, but I'll walk you through it. So I want to find the average weight for each product. So the column of interest is pounds, and then I'm aggregating by each product, and then I'm finding the mean. And if I run line 110, and I can take a look at average weight per product, we can tell that the average weight for ash, each purchase is 151 pounds. The average weight for cedar is 163 pounds, and the average weight for pine is 187 pounds. So that's just another way of aggregating data in R and doing some basic analyses. And the last example that I'll give you today is actually involving naming columns. So we can see that we've created this this new data set, average weight product. When we did this aggregation function, we can open up this window and we get these values. But as you can tell, the column names are a little bit awkward. We have this group.1, which is, it stands for the groups that we're aggregating by. And then the X's are, kind of column of interest. They're not that intuitive, those column names. So if we wanted to actually rename those columns, we can use the names function. So we do call names, and then we type average weight products, because that's the data frame that we would like to change. And then we can use the concatenate function. And then the first column that we wanted to rename was, we wanted to call it product, because when you looked in here, group 1 is describing the products. So I'm going to call that product. And then the second column was the average weight. So I can call that average weight. So I'm just renaming the columns within the data frame called average weight. And if I run line 113, I can open it up in my console, and we can see that now we have a column 1 that's equal to product, column 2 is equal to average weight. And I can actually click up here in this previous window, and we can see that the names have already been changed. So that concludes all of the assignments from class 3. Hopefully you guys learned a lot today, and stay tuned for class 4. I probably will be only posting the first 3 classes of this 24-part series on YouTube. So class 4 is going to be for subscribers only. So if you would like to continue on with this course, please go to fldatascience.com, where you can subscribe to this tutorial series, and you can become proficient as a data scientist. And thanks a lot for your interest in this course, and stay tuned for more information. Thanks.